Hi, my name is Alex Hutchins, and in this video I'm going to be talking about titration. So titration is the process of adding one solution of a known concentration, this is called the titrant, to a solution with a known volume and unknown concentration called the titrand or analyte until the reaction is neutralized to determine the concentration of the analyte. So titration is used in real-world laboratory settings to determine concentrations of chemicals in blood or urine, which is important for medical testing and things like that. And it's also used to develop new medicines, so pharmacists use it to develop dosages and determine the chemicals in those, and then we also use it in the food safety aspect to determine the concentration of chemicals in certain foods. So first we have the titrant and analyte, which is what I was just telling you about. The titrant is the solution of known concentration that is added to the analyte to determine its concentration. Then the analyte is the solution we are trying to find the concentration of. And here's an image to kind of demonstrate that. Burette is used to measure out and deliver a known volume of titrant. The ring stand is used to hold the burette above the flask of analyte, and the clamp is used to attach the burette to the ring stand. The Erlenmeyer flask is what will hold the analyte. This is used rather than a regular beaker so that the experimenter is able to mix the materials together without the risk of spillage. We also have distilled water, which is used to clean out materials and prevent titrant from sticking to the sides of the burette. Lastly, we have the indicator, which is added to the analyte because it will change color in response to a chemical change that occurs to the experiment. And there are lots of different types of indicators that will turn lots of different colors, so I haven't included an image here because it could be so many different things. So as we saw in the photos, you're going to want to position the burette or clamp over the flask in order to perform the titration. And you're going to fill the burette with titrant and make sure that the stopcock is closed. Then record the starting volume of the titrant in the burette, and remember to add one significant figure beyond what graduation measures in order to improve accuracy and precision. So this is important to know for calculating the concentration of the analyte, which is like the point of the titration. So you're also going to want to add indicator to the analyte and record the volume of the analytes that's in the Erlenmeyer flask. So you're going to open the stopcock and allow titrant to flow into the analyte and swirl the flask with the free hand to ensure that it's being thoroughly mixed. You'll keep adding titrant until the color of the analyte begins to change. Then the stopcock can be adjusted to keep the titrant from flowing so quickly. You're going to want to stop when the titrant has fully changed color and the indicator takes longer to fade into the color, so it should be kind of a palish color and not a dark color, because a dark color would indicate that it has been over titrated, and we do not want that. So you'll want to record the final volume of the amount in the burette of titrant, and this can be subtracted, the initial can be subtracted from the final to determine how much titrant was added into your solution. And then you probably want to repeat this process 3 times to improve the precision and accuracy of your results. And then once you are done with that and you have like an average amount of titrant that's added and you feel pretty good about your results, then you can use the stoichiometric ratio that is used or found in your equation, your chemical equation for the process that you just conducted, and this can be used to calculate the concentration of the analyte, which is unknown and what you are looking for. So yeah, I hope that you learned all about titration, and see you next time. Thank you for watching, and I hope you enjoyed this presentation, a brief overview on titration, and that you learned all about it. Thank you.